Hey everyone, and welcome to Graph Properties of Log and Ln. So in a couple previous videos, we've kind of done some algebra stuff with log and Ln, as well as some evaluation. But now we're going to look at, okay, well, how do we graph these things? So what we're going to learn today, we're going to learn how to graph log and Ln, and we're also going to learn how to find the domain, range, x-intercept, y-intercept, and any asymptotes that may be hiding in our graph. So first off, let's look at the parent graph, so the graph of log x. So here are some inputs that we've chosen: 0, 10 to the negative 10, 0.001, 1 over 10, 1, 10, 100, 1 times 10 to the 7th. This is also known as 1 million. So notice as, first off, when we plug in 0, we get something undefined. So that's an observation here. This thing is not defined at 0. In other words, log of 0 does not exist. Okay. What else have we noticed here? We've also can see, hey, our inputs go from 0 up to like a million, and our outputs only go from negative 10 to 7. So inputs 0 to a million, outputs negative 10 to 7. So another observation is log grows painfully slow. Very, very slow growth, which makes sense because it's the inverse of an exponential, and exponential is very fast growth. So log grows slow. Another observation is we can see, so since we're not defined at 0, we can also see from the picture of this graph here that it looks like we have a vertical asymptote also at the line x equals 0 because we never actually touch there. So these graphs do have asymptotes at the vertical line x equals 0. So it's not defined at 0. It's also not defined for anything less than 0. So these log functions are also only defined for inputs, or x's, that are strictly greater than 0. Notice when we plug in 0, and if we plugged in any negatives, we'd also get undefined. So these functions are only defined on the positive value. So you can only input positives. So that restricts the domain. Let's look at some end behavior here. So f of x goes to infinity as x goes to infinity. So as x goes to infinity, or as we go along the graph to the right, the graph will eventually go up. It doesn't stop. There's no horizontal asymptote in this case. It does go up. It will eventually reach infinity. It's just going to literally take an infinite amount of time for it to get there. Let's look at the opposite end behavior. So f of x then takes a nosedive to negative infinity as x goes to 0. So as we travel, we go to x is 0. What is the function doing? It's taking a dive down to negative infinity. So f of x goes to negative infinity as x goes to 0. So there's a couple observations here about our parent graph. These will help us with any transformations of the parent graph that we have in a couple graph properties. So here are some more specific graph properties. So for log-based a of x, given that a is greater than 1, we will primarily live in here. Very, very, very rarely do you have a situation where a is between 0 and 1. It's not likely, and again, we don't really use it that often. In the real world, it's almost not used at all. So if log-based a of x, where a is greater than 1, so we're talking 2, 3, 4, 5, 6, 7, anything, the domain is all positive real numbers, because like we just noticed from our observation, we can only plug in positive numbers. So the domain is from 0 to infinity. The range, we do go all the way down to negative infinity, and this will eventually rise all the way up to positive infinity. So the general range is negative infinity to infinity. Of the parent graph, the vertical asymptote is at x equals 0, or the y-axis. It gets really, 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 really close, but never touches. It's increasing the entire time, so we don't like have a bunch of bumps like we did in polynomials. And the inverse function is the exponential a to the x. Okay. When a is between 0 and 1, we look like we kind of flip it over But again, we're not going to talk about this too much. You can pause the video and take down these facts. This rarely happens, mostly because we can just do a change of base formula on it and make it a little easier for us. So let's look at some examples. So what if I wanted to find the domain, range, x-intercept, y-intercept, and asymptote of f of x equals ln to the negative x? Well, first let me look at a table. Okay, so I've plugged in a couple values, -4, -3, -2, -1, 0, and 1. And then I also created a graph. And then that stuff didn't get on my graph. So notice when I plug in negatives, I'm defined on all the negatives, right? And I start to be undefined on the positives. Why? Well, because of this negative sign here. That's basically saying whatever we plugged into x, we're going to flip the sign on it. So regular log and regular ln is defined on all the positives. So ln of negative x, the domain of this, is going to be defined on all the negatives. See? Once we get to 0, we start being undefined, so it's defined on all the negatives until we get to 0. The range looks like we still go from negative infinity. This is still going to go up. The range is still going to go from negative infinity to infinity. And x-intercept. So where does this thing cross the x-axis? It crosses here when x equals -1, as we could also see right here from the table. So at -1, 0. -1, not x, -1, 0. The y-intercept, in this case, we can see it never actually hits y, so we don't have one. And the asymptote is right here again at the line x equals 0, or the y-axis. We get really close to the y-axis, but we never actually touch. So the asymptote is at the line x equals 0. Okay, let's see one more example. Let's see some vertical, horizontal magnitude shifts here. Let me move my pen. Okay, so what if now we were asked to find the domain, range, x-intercept, y-intercept, and asymptotes for f of x equals 3 log base 2 of x minus 1. Okay, how do we start going about it? Well, we're going to first look at the parent graph, which is log base 2 of x, gather some observations about that, and then notice that this is a vertical stretch of a factor of a multiple of 3, and this here is a horizontal shift. And horizontal shifts are always opposite, so we would think that's to the left, but it's actually to the right. The right one. Okay, so we're going to look at the parent graph, and we're going to apply the stretch, and we're going to apply the shift, and then we're going to see where we land to get kind of a sketch of this. So the parent graph is here, log base 2 of x. -1 undefined, 0 undefined. We don't start being defined until 1. So of the parent graph, our x-intercept is 1, and our domain is all positives. And we plug in 1, 0, 2 to 1, 4 to 2, 8 we get 3, 16 we get 4, and so on. So that graph is here. Okay, now we're going to horizontally shift it to the right one. So take everything and move it to the right one, which means our new intercept, so our new x-intercept is going to be here at 2. So x-intercept is going to be at 2. Okay, so that's what changed there. Our old x-intercept was at 1. Our new x-intercept is now 2 because we've horizontally shifted to the right. The next thing we're going to do is vertically stretch it by a factor of 3. So we're going to take all of the y values, and the positives are going to get more positive, and the negatives are going to get more negative. Let's see, so this impacts the range. Actually, not at all, because that range is still going to go from negative infinity to positive infinity. Now let's look at the domain. So our domain now, let's see, our old domain was all positives, we're good. Our new domain, notice now at 1, we're now undefined. Okay, so our new domain now, we need to be bigger than 1. So our new domain is going to now go from 1 to infinity, where our old domain was 0 to infinity, but we shifted to the right by 1. So that's what happens to the domain. Okay, the y-intercept. Oh, again, it looks like we don't have one, so that's a DNE. And let's see, what thing are we missing? Our asymptote also got moved over by 1. Our old asymptote was at x equals 0. We horizontally shift right 1, so now our new asymptote is at x equals 1. Our new vertical asymptote is there. Okay, so how to handle shifts. So again, know the stuff you need to know about the parent graph, and then do your shifts and transformations accordingly, and then apply that to your new information. So we now know how to graph log and ln. We know how to find domain, range, x-intercepts, y-intercept, and asymptotes. Great job. So if you have any questions, please, is like I always say, please don't hesitate to ask. I'm here for you guys, and I'll see you guys in the next video.